This is the second part to lesson 1.5, using graphs and tables of functions. A function does not need to be defined by a formula in order to create a table. So in the last video for lesson 1.5 we were looking at graphs. Now we're going to look at tables, and we know we don't need to have a formula in order to create a table. A function can simply be defined as a set of ordered pairs. In this case, the domain and range is limited, and this is very important. It's limited to the values of the ordered pairs. We're not going to say x is greater than or equal to 1, or we're not going to do set builder notation anymore. We're not going to say x has to be such that x is greater than or equal to 1 and less than or equal to 10. Not with tables. With tables, we just list the ordered pairs for the domain and range. So let's go through an example so you can see that. Example 2a. In 2000, the CDC found the mean height h in centimeters for girls in the U.S. at various ages a, where h equals f of a. So we know f of a is the independent, h is the dependent. Some of these data are given in this table. What is the domain of the function defined by the table? So we know that the domain is the independent, so it's going to be all those a values. But we're not going to write it using set builder notation. We're going to write it differently this time. So if we know the independent equals a, and that's the domain, we're going to say domain, and we're going to put a colon, and we're going to say that's a brace, 2, 4, 6, 8, and 10. Those are the values that I put around or put inside that rectangle. 2, 4, 6, 8, and 10. It's only those values for the domain. For the range, we know it's the dependent, and that's the h values, equals the range. So we can write it range and a brace, 85, 101, 115, 127, and 138. Find f of 6. What does this represent? F of 6, so if we go in at the a, so f of a was f of 6, that's right there. F of 6 equals 115. So f of 6 equals 115. For the a value of 6, the h value is 116. And what this means, at age 6, girls in the U.S. have an average height of 115 centimeters. For what value of a does f of a equal 138? So this time we're looking for that a value. 1h is 138. So here's 138. The a value is 10. So f of a equals 138 when a equals 10. And that means that, well, if you work it backwards, when this girl is 10, the average height is 138 centimeters. Example 2b. Robert Wadlow is the tallest person in medical history whose height has been substantiated. At birth, he was of normal height. The table on the right gives his height h. So here's the height h at various ages a. So a and h, where h equals f of a, and that's really important. So f of a, so a is the independent, a is the controlling one, h is the dependent. So what is the domain of the function defined by this table? So the independent equals the domain, and it's usually going to be the top line of the table, equals the a values. So it represents the years. So if we write it, we would say domain 8, 10, 16, 18, and it's all those values. If those values were to repeat, then you wouldn't write them again. You would just write it once. So if it was all 3s, you'd only write 1 3 inside of the braces. So what is the range of the function but defined by this table? Dependent equals range equals h. The dependent is the h values or the height, and it's going to be 1.9, 2.0, 2.4, 2.5. This should all fit on one line, but it's too many. And that's the range, all those values that I just wrote. Find f of 16. What does this represent? So f of 16 is f of a. So a is 16, so the age is 16. The height is 2.4 meters. So f of 16 equals 2.4 meters. That means when Robert was 16 years old, his height was 2.4 meters. That was C. And then D. For what value of A does f of A equal 2.7? So f of A equals 2.7. 2.7 is the height h, and that's in meters. When h is 2.7, I'm circling it on the table, his age was 22. So when A equals 22. In other words, when he was 22, his height was 2.7 meters.